Loud and clear. Thanks, Jeff. Hi, everybody. Thanks for coming. Um, if you're here, you probably know that what I'm going to do is recap a talk I gave just over a week ago in Boston at AWS Reinforce, which is our annual security conference. Only the second time we've had it in person due to COVID interruptions, but it was great fun being there, and um, it's a security focused conference and a lot of security practitioners there and um, a lot of folks I haven't seen in person in years. That was a really fun part of it too. And I'm gonna hopefully this we'll see if this works. So it's the talk I gave. I actually it was part of a few talks. We did a leadership session too, which had some crossover with this, and it was just all about how we think about data and data security at AWS and what we mean by security is our number one priority, right? What does that actually translate into? And this talk's going to, cover a bunch of that too. The talk I gave is recorded; it's on YouTube, and I'll put a link to that in later, and I'll tweet that out as well. So what I'm hoping to do here on Twitch is if people have questions or anything they want to dive into deeper, happy to do that. There's ways we can make this interactive since we've got the chat going and put a bit of a different take on it because why do it exactly the same when you've got this opportunity? But the um, the topic is AWS and confidentiality and how is it that we keep our customer data confidential and secure, even from us, even from ourselves or anybody else, right? To run web services on behalf of customers is a big responsibility, and customers store, you know, all sorts of data sets with us, um, some of which are sensitive, right, and contain people's personal details or business information or proprietary trade secrets and things like that. And our customers certainly want the highest levels of assurance around that and making sure that it is kept secure at all times and that we've got strong technology and procedures around that. And I think this is increasingly important in the industry. All sorts of data is being processed by online systems these days, and the practices and processes that businesses need to have are constantly evolving to make sure that they've got a high standard of protection around that. And I wanted to share a bunch of ours. And so, but I want to start with some examples of just what this kind of turns into in the real world. What does this mean? And one of my favorite examples is what happens if you call AWS support and you need help, right? Now, the AWS support team, they love helping people. That is what they live for. I've gotten to work with them a bunch and sit down with them and actually take, customer questions. We actually have this process at Amazon where we're encouraged to do that every so often. It's pretty cool. And I can tell you, in my experience, those folks are motivated. They really, really want to help customers. And if anything is ever bubbling up as like, oh, we've got this common pain point or whatever, they want to get on that and they want to make sure um, customers don't have to deal with it. And when I joined the industry, like when I started, my professional career over 20 years ago now, it was still pretty common that support and help desks and sysadmins would kind of just have carte blanche access to everything. Like you could call up a service provider, like an ISP or your email provider or whatever, and those people might, often just be able to fix things for you, right? They're just able to like, oh, we'll just go into your account and we'll change this setting and we'll do X, Y, Z, and yeah, hey, you're good now. Or, they could go, um, they could go open things on your behalf and so on. Like that was really common. That's never been common at AWS. By the time AWS even kind of began, um, I think that philosophy had died. Like that old school way of like, oh, there's just these, God mode or God level administrative privileges that are used internally. had died. I think there's still parts of the industry that's in, and there's still companies out there that operate like that, but it's less and less common because I think we all realize that, you know, it just can't be like that. That's just not a good way of handling business. And so, we're very much like that. AWS support cannot just, go access a customer's EC2 instances or data in their S3 buckets or anything like that. In fact, um, the way it is done is that there is a dedicated role that AWS support can use to help customers, and it does give them access to some um, metadata, just very basic things about a customer's configuration and so on. And we're very transparent about it. We actually publish like what is it that AWS support can see, other people can weigh in on whether they think that's right or not, and so on. So there's lots of transparency and accountability, and customers have to explicitly grant anything beyond that, and they can even revoke some, those permissions. They can go break things if they want. If they're not comfortable with even that, very minimum level that's there, they can go break it if they feel like it. Another example is the EC2 Nitro system. So I work on EC2. Um, that's my day job. I work on the EC2 Nitro system, which is this platform we built that runs all of our modern EC2 instance types. And I don't mean to brag, but I am like literally at the most senior level of EC2 engineers, right? Like, and I'm also been there a long time, right? Like, I'm pretty well trusted. I like to believe, and it makes no difference. I have no access. Like, there's no way where I can like log into a Nitro system and like run commands or like find a way to get access to customers' data on an EC2 instance, and so on. And that is a pain sometimes, right? Like if there's an issue in production, like a really weird case that a customer has hit, maybe a subtle performance issue or something like that, it is a real pain to try and do diagnostics or debugging on that because I can't just go attach a debugger or get rich diagnostic logs out of that system or anything like that. Um, it's extremely locked down, and that's very intentional. It can mean we might have to work harder with that customer and say, hey, I can't, we just don't have enough access to be able to diagnose things here. Would you mind reproducing the workload on one of our platforms where we do have access, but like that's very consensual and known, and the customer knows we're doing that, right? But in the normal default like production case, I don't have that access. There's no way to turn it on. It's just for me, it's a hermetic system. It's hermetically sealed. I can't get that kind of data in or out of it. And both of these are examples of kind of a core philosophy we have in our business, which is that we consider customer data radioactive to us. We never want to see it. We never want to touch it. And we want to build shielding around it so that we don't have to see it or touch it. Um, and increasingly, we're now giving customers the same tools so that they can do the same, right? So that they can shield their operators and administrators and developers from their customers' data or their users' data. And so this is what I mean by, I think of it like we're safekeeping without the combination. Like we're running a service, we're, storing something for customers inside a nice, secure safe, but we don't know the combination. Like I won't be able to open that safe and look inside or do things. Um, um, and as I said, I think this attitude and approach is becoming increasingly common, and I'm going to go through some tools and business processes that I hope are really useful and helpful for people in kind of building this into their business and their way of doing things. And I'm going to get into some nuances of why sometimes other approaches might not be good enough. And so we'll see that. Now, to get into all this kind of material, I have to give you some disclaimers. Um, we've got an ace team of lawyers who, who make sure I say the right things. And one thing that's important here is everything we're talking about today can be, part of how a customer achieves compliance. Often compliance authorities, both internal and external to the customer, or regulators and regulatory authorities, governments, and so on, can require customers to like, hey, you have to be able to prove you can't see X, Y, Z, and so on, right? But we have compliance is never as simple as just checking a box. It's always situational and usually specific. So don't take anything I'm about to say as, oh, well, if I just implement this, I get compliance, right? Instead, work with our AWS compliance team. They love helping customers too. Uh, Another disclaimer is that just to cover this topic, I'm going to cover some movie plot threat models, right? We're going to consider threats that are really exciting and interesting, but also very, very unlikely. And the kind of things you see in a movie plot or a fun suspense novel. So keep that in mind. And then the last disclaimer is, if you've got specific interest in our approaches to data privacy or data privacy, whichever way you say it, we've got a data privacy center with lots of facts and statements and stuff from our CISO and our CISO's team and so on there. And, have at it. All right, so with the disclaimers done, whenever I'm talking about a security topic, whenever I'm approaching anything to do with security, I like to start with a threat model. Like, what are you actually defending against? And what we're defending against is, well, we're hosting customer data, obviously, customer data in S3, Dynamo, Kinesis, all sorts of systems at AWS. We want defense in depth against any bugs or issues in those systems, right? So that's not even malicious necessarily, right? We just want to make sure that as much as possible, if there are issues and bugs, that we have layers of defense. We want defense in depth against operational errors and mistakes, right? We want to make it so that somebody can't just inadvertently happen upon some data or anything like that. And we also want defense against untrusted access, including insiders, right? Including insider threats. And this is where, those movie plots come up, like, what happens if, hey, well, you're a trusted operator, but what happens if they kidnap your family and then the, person is holding a gun to their head and they're going to tell you, you got to give me this data or going to shoot your family and all this crazy kind of stuff, that doesn't happen in the real world as far as I know. But at the same time, these kinds of threat models do think about this concept that just because somebody's an insider, just because somebody's worked here, just even for a long time, that doesn't mean they should have access, right? And you want to neutralize even those crazy movie plot threats. And what all this boils down to is essentially we just want to constantly raise the bar for the principle of least privilege. We don't make sure that things only have access to data if they truly need it on an as needed basis. And hopefully you'll get a flavor of like just how hyper specific like truly need is for us, like way beyond what you might be used to. And we want to integrate. We want to lock down systems. We want to be preventative, but we also want detective controls. We want to be sure that, well, if anything did go wrong, if anything even close to something that shouldn't happen happens, we want to know. So we want to have controls that are there, just looking at what's going on at all times and so on. And then we want to integrate really simple, and that's simplicity is really important here, strong isolation into our systems, because isolation is so important to us. It's the most important layer of defense. So we want it to be there, and we want it to be simple, because the simpler it is, the less likely it is to fail. Great. So in general, right, when you've got anything you want to get done in life or in business, especially in business, right, you kind of have to ask yourself, well, how do I go make it happen? So in our case here, we're trying to, raise the bar for the principle of least privilege and raise the bar for how securely we isolate our systems and data and so on. Well, in my opinion, you want to start with a way to measure it, right? You want to be able to measure how are we doing? Like you want to be able to baseline yourself and see, well, what state our systems in, from say like a really old school way of thinking, like, oh, this is a wide open system, anybody can access it, that's bad, all the way up to a completely hermetic system like Nitro, right? But it's useful to have a way to measure that. I'm going to give you a way. And then when you've got a way to measure that, well, now you can drive systems. You can say, hey, you're like a wide open system. That's no good. I need you to be a much more stringent system. So how do we get you there? And The other important aspect of why it's important to be able to measure things is that not all systems and services need the same levels of protection, right? We A good example of that is, okay, so the Nitro system I think needs a very high level of protection. Like it needs to be that I can't access customer data through the Nitro system. That just needs to be a fact, and that's what we've done. But another system, say that's running, say, our public website, well, that doesn't need the same level of protection. All that data is public anyway. It's all published on the internet, right? So if I can log into our web server that's running the public website, there is some sensitive data there to sort of, the access logs contain, which IP addresses access which web pages at any given time, and that deserves some level of protection. But it's not the same level of protection as, say, data in S3 or data in an EC2 instance. And so to help measure these distinctions and figure out, do we have the appropriate level of protection in systems, we have this framework that's all about driving systems and seeing how we can constantly ratchet and raise the bar on the levels of protection. And if you think about the principle of least privilege, what's the absolute least privilege you could have on something? Well, it's zero, right? So it's called the zero privilege operations framework. And the idea here is, aspirationally, we want systems, people in general, to have zero privileges over data, right? So how do we get there? And there's 5 different levels in this framework. I'm going to go through them all, and we'll see how they interact and provide increasingly better levels of protection, and then I'll show you what kind of levels we use for some of our systems. It's you can kind of think of it like a maturity framework. It's not designed to be a compliance framework or anything like that, but this could certainly interact with compliance frameworks. But I find it a very useful way to kind of be able to point at a system and say, well, is that a level 3 system? Is that a level 5 system? And so on. And just help me assess, is that system ready or okay to host certain kinds of data and so on. So let's start, and we'll get through the levels. So the first level is just foundational principles, and the key here with the foundational principles is, I think, a framework like this, especially when we're working with customers, it's actually always great to have a level that you can kind of get started on very, very quickly and very, very easily. And I would say that, adopting level 1 of this framework is something almost any business can do, or any team can do in like a day or a week at most of work. Because all it's about is really saying that we, as a team, as a business, as an organization, as a nonprofit or as the government entity, whatever it is, we basically are going to take this attitude that we shouldn't have access to the data. That's just going to be a way we operate our business. And that's a really important decision, because that does have some implications, right? It's not free, right? Just making that decision implies, well, now you're going to have to build some systems and tools that might be a bit of an inconvenience. You're going to have to change your procedures and processes a little. And you're taking on a role where you kind of want to always be asking, what would the customer want us to do, right? And honoring the spirit of that question at all times. I think it's obviously a really great positive attitude for any organization to adopt, but it's an explicit decision. And then just some things that come along with taking that decision are, well, something you're going to have to do pretty early is to figure out how to classify data, right? You're going to have to kind of sit down and write down, like, what's relatively innocuous data that we're not as worried about protecting, and what's very sensitive data that is. So, maybe configuration data isn't as sensitive as, PII, right? Whatever's right for your organization. But that's going to have to do some kind of inventory and classification step. And you're going to have to sit down and build feedback mechanisms with employees and operators, administrators, developers, folks who work on these systems, because you could just put your fist down and say, okay, no one's going to have access to data starting on this date or whatever. But you just do that, odds are it's not going to work, right? It needs consensus and buy-in from everybody involved. And I think it needs good feedback mechanisms because people are going to have to adapt the way they run these systems. And you want to be able to make sure that that's sustainable, that people aren't being burned out, that they don't have to work around controls and so on. Being a bit self-critical, this is something we learned the hard way at Amazon. So at Amazon, we took a security is our top priority approach. So that means we're just going to lock all these systems down. And in some cases, made them too hard to operate, right? And the reality is you don't really get the security benefit you want until it's sustainable, because you don't want people having to kind of work around the security controls ever, right? So this has to go hand in hand with building automation and reducing, any burden of manual activity and so on. And which is a good thing, right? It's actually it promotes and encourages great operational practices anyway. We do have some tools and services that can help you with this. Amazon Comprehend, one of our machine learning based services, actually has this mode where you can spin it up and point it at like your S3 bucket, and it can help you identify and classify data. It can find strings and like, hey, that looks like a credit card number, that looks like a social security number, that looks like, and so on. And so there are actually pretty cool tools out there, including Comprehend, that, automate and help some of this. But, for the most part, level one isn't so much about, tools and so on. It's mostly a philosophical thing, even, right? Just adopting this idea that, hey, we're going to be the kind of place where we don't want to actually have access to data. I think that's a really important first step for a lot of folks. Now, the next level in the framework is just the elemental protections, like the table stakes kind of stuff that you'd expect to see in terms of how systems are accessed and managed, right? And, if you're a security engineer or a security professional, I don't think you're going to be surprised by much that's in this list. And a lot of it's going to seem mundane, although I'll say a lot of it is missing in a lot of real world deployments out there. Thankfully not in cloud environments on AWS, but in level two are things like, well, let's make sure that the physical storage of data is secure against theft. Like make sure we're encrypting all the hard drives, whether that's on a server or a laptop, right? Like, you don't want some employee's laptop being stolen out of their backpack, to mean customer data is at risk, right? That seems like a pretty basic level of protection, right? That we've got network encryption, right? So no one could just, tap an Ethernet cable and seeing what's going on or anything like that. That you've got fully tested backup and restore processes, which people, is an important business continuity practice, but is increasingly important because of ransomware, which, is a real world threat for many customers. And that you've got, secure multi-factor auth and so on for operators, so they can't just be phished in the first place. Things like that. At AWS, just one little point of detail here, we encrypt all of our network traffic. Every physical link that's outside AWS control, anything between our data centers, anything between regions, it's all encrypted. We have another layer of encryption on top of that, well, several actually, but we've got VPC encryption, which is also encrypting all the traffic between EC2 instances that support it on our VPC network SDN and so on. And so we've got several layers of that network encryption, just kind of always on. This can be customers often have to ask us about this, so it's just a useful useful point to get out there. We support at-rest encryption on all sorts of durable services, EBS, S3, Dynamo, like anywhere you want to store data, we can encrypt it. And customers can encrypt it too. Right? Customers can encrypt their data and upload before they upload it to AWS, right? And then it's completely opaque, and you get another layer of defense and so on. We've got our AWS backup, so you've got fully tested backup and restore and so on. And we've got MFA built into our authentication services and so on. So if you're on AWS, typically it's pretty straightforward to be able to get all these elemental protections. Just make sure that you're setting up MFA and using encryption where you can, and making sure you've got a backup restore and so on. So as I said, it might seem mundane, although in traditional or on-premises environments, dare I call them legacy at this point, it's a bit of a different world, and these things aren't as common there. So then we'll move up to level 3. So it's a lot of businesses are used to driving things to level 2 already. Right? A lot of corporate businesses, especially, they insist every laptop is encrypted, and so on, right? Or that they have MFA. Level 3 is starting to get a bit more interesting, and a bit more advanced than I think you typically see. And it's all about having immutable accountability, which essentially means, look, anything happens, whether it's a software change or a configuration change or an operator doing something, we gotta have a robust, accountable audit trail of that happening. Like, there can't be any way for anything to happen silently in the system. Like, this is, this is really important. And so this is about regularly baselining who has access to what systems, what do those systems have access to, and so on, and to constantly be reviewing that. This is something we do a lot of at Amazon. If I have a permissions group for who is allowed to operate a system, I have to regularly reassert, yes, this is the correct set of people that have access to that, and so on. And then we have annual, or at least annual, sometimes more often, processes that are asking us to check, is the level of data or whatever this system has access to appropriate? And are there any new ways we can lock it down? Because we want one-way ratchets, and all of these things. It's pretty cool. All right, I've got a question from Jeff, so I'm going to pause to handle it. He's asking, given what he learned at the Nitro System Networking event earlier this week, that was, I believe, was AWS Silicon Innovation Day, which was on Wednesday, also here on Twitch, that it can encrypt streams at network speed without needing memory buffers. Is it the case that we get some of this internal protection for free without adding measurable latency or burning CPU time? Yes. So the Nitro cards, the Nitro system perform both network encryption and EBS storage encryption for you at line rate on external cards. So they're not taking any resources from the hardware your EC2 instance is running on. They're separate cards with their own CPUs and their own hardware encryption chips that have been custom designed to be able to do that incredibly quickly. That is one of the keys to the Nitro system, because we want all the security benefits of the Nitro system. I'll talk more about that, but the performance benefits are pretty real too, because the alternative would be to do the encryption directly on the system where your instance is running, and that's not friendly with schedulers. It's not friendly with your CPU pipeline. There's a bunch of hits that would impose, but Nitro kind of skirts around that by being this external box. All right, so we'll get back to level 3 though. So the next part of making sure that we've got real accountability is, well, you can't have any shared accounts, right? So I've seen it still be common out there where, with customers, that sometimes they've just got an admin account that they use to log into boxes. And it could be as simple as they just share that password with all the admins. But if something happens on that box, well, you don't actually know who did it. You just know someone logged in as admin, right? And that's not great. We don't have that practice at Amazon. In fact, where we do have login capabilities to any boxes, we actually have our own individual accounts in our own names on those boxes, so that activity can be attributed all the way back to the person. Roles are a better way of doing this. So with the IAM system, you can assume roles. and then you get the capability of the role. You can do whatever the role is allowed to do, but it's still traceable. You can see who assumed the role and so on. And it's really important that this can be traced end to end, because if you don't have this accountability, I mean, how can you really enforce anything, right? Um, the oh man, I should have updated the slide because we renamed AWS SSO to AWS Identity Center last week. But we've got these properties built in to IAM, to AWS Identity Center, to Systems Manager, to Instance Connect. All of these systems give you end-to-end traceability, which is really, really useful. We also, for API calls or folks using the console, got AWS CloudTrail, AWS Config, which are great ways to see, something's changed, like who made that change, what changed, right? That all gets logged, can all be stored. There are great ways to configure these where, those go into separate S3 buckets that are really locked down and nobody can just go delete the logs and so on. And we also have, you can do on-box monitoring with systems like Guard Duty, and you can do network level monitoring with things like VPC traffic mirroring. So we've got all sorts of ways on AWS where these can be done. And I'd say if you don't do anything else, it is worth enabling CloudTrail for management and data events. Just going into console only takes a few minutes, but if you enable CloudTrail management and data events, and have at least that set up, I think that you can do that in 5 minutes. An hour if you really want to double check everything. It is invaluable because if anything ever goes wrong someday, whether it's a security issue or maybe even an operational issue, somebody deleted the wrong thing or something like that, it'll just give you this rich log of like what happened, when, who, right? Which is just invaluable for then figuring out how you're going to fix it. And I would beg any customer to enable this, because it's really, really helpful. And then, so internally at AWS, we also insist on having immutable accountability between our systems, right? So we could have built our systems so that, like, imagine you're using two AWS services that have to talk to each other. So I'll just pick a simple example, which I'll cover in more detail later. But let's say when ELB needs to get your SSL certificate. So your SSL certificate is actually stored in ACM, and the key for that certificate is stored in KMS, right? So that's three services that now have to work together for you to do something. Now, we could have just built this wide open, trusted system, right? We could have just said, hey, they're all internal services. ELB could just ask ACM for a certificate, and it can just ask KMS for a key, and it'll just get it. That is not how it works. That's not what we built. Instead, all of our internal calls are fully authenticated and encrypted using our normal SIGV4 protocol, just like external calls to AWS are. And all of the access between these systems is mediated by principals, roles, policies, and it's all through the ring-fenced IAM service that, service teams kind of work around or subvert or anything like that. And this means we can put transparency and consent kind of front and center, and that what a service is able to do on a customer's behalf is public and known. In fact, we actually publish managed policies. If you go look through our documentation, you'll find all sorts of examples. Here's the Elastic Load Balancing managed policy, which describes like what is this service able to do on a customer's behalf? What else at AWS is it allowed to call, and how does it call it? So this is a really, really strong level of accountability. And customers can even revoke and break this access if they want in some cases. They can put explicit denies out there if they prefer to break it for some reason, if they had some kind of concern. The detail in these managed policies can be a little intimidating. If you look at the full managed policy, it can run to tens of items, and you might be a little intimidated by it and not understand it. But a great tool is to use the IAM Access Analyzer tool, which is how we ourselves kind of analyze these policies. And that can give you really, really great synopsis of what a policy does. You can paste a policy into it, and it can give you, interesting summaries of Like, well, what does that mean the policy can do in much more simple terms? What can it actually access? And also, it can tell you if you want to look at resources, it can tell you who can access them and so on. And it's just this really, awesome tool. If you have to work on IAM or policies or permissions ever as part of your job, I really strongly recommend learning the Access Analyzer tool. It is an incredible power tool, um, huge accelerator for productivity. But all of this, right? The fact that we use authenticated calls, that everything is accountable, means we get this kind of immutable accountability internally um, between these systems, right? And that gets us to level three. And level three, um, level three is a great level in my opinion. I think level three is good, right? Like, and it's kind of our minimum. It's kind of what we think of as our table stakes. It's also a very achievable minimum for customers, for AWS customers, right? If you're running on the AWS, um, it's pretty easy to enable all these things, right? Like to enable MFA and get yourself to level two and so on, and then to enable CloudTrail and get yourself to level three, right? And that's actually a pretty gigantic leap ahead of what somebody who's on prem might be able to do. Like, it's just really, it's a lot more work to get to level three, in a traditional environment, right? How do you build those um, audit trails when you don't even necessarily have everything going through APIs, right? So you can kind of start to see the benefits of having everything logged like that. But level three is good. It's a nice minimum, but we want to be able to go far beyond that, especially when we're handling more sensitive data. So levels 4 and 5 are where things get even more interesting. So level 4 is about contingent authorization. And it's this idea that, any access a system has should be very specific and very conditional. We only want to grant access to data because it's needed and while it's needed. And we want systems that prove they need that access and prove they're entitled to that access. And we want the systems to be robust, especially against like a bug or an issue that could lead to a compromise, whether that's because there's just some vulnerability in the software and now the system can be accessed inappropriately, or because of an untrusted insider or something like that. We don't want the mere fact of like getting into that system or being able to get into that system to mean, oh, now the data is disclosed, right? That's not. We want to do a bit better than that with contingent authorization. And so we've got many examples of that, but one I'm going to walk you through here is that case of how ELB accesses your certificate and its key. So as I said, the ELB service, when it's calling ACM and KMS, uses the AWS SIG-v4 protocol. And if you want more detail on that, I wrote a blog post. There's the URL that gets into very minute detail about how that signing process works. And I think the first kind of interesting thing about how that process works is that um, the signature itself, the way a request is authenticated, it doesn't just use a customer's secret key, right? So when you create an AWS account or user, you can get back, some secret credentials from us, and then we forget them. Like, you get one opportunity to get them, and um, and those credentials can, we could have built it so that those credentials are used directly to sign every request, right? But that's not great, because then the other side that's authenticating a request will just have to know those credentials. And if that system were ever compromised, it'd be game over. We'd have to go rotate everybody's credentials, right? There'd be a huge blast radius associated with an issue like that. So that's not how it works. Instead, the signing protocol actually derives very, very specific keys that are used to sign requests. And in fact, the keys that they derived are unique for every day, for each service, for each region. So the actual key that's used to sign your request is a per day, per service, per region key, right? So if you take that issue again, imagine there's some vulnerability in the service, a reason why that service is having a problem, and that key were somehow disclosed. Well, all that's implicated is access to that service in that region for that day, right? And that was already implicated because the issue happened to that service on that day in that region, right? So it made it no worse, right? It's highly conditional, highly contingent, right? This is what I mean by just how small we take the principle of least privilege. Um, we've actually recently launched SigV4A, which uses public-private key cryptography to do even better than this again, to actually sign requests with private keys, which rather than symmetric keys, which is actually something no one's ever really done before because it's computationally more expensive. But we really, really do want to be able to ratchet the security. So that's one level that's going on. But another level is that, okay, so again, we could have made it so that, like, well, you call ELB and we authenticate the API call, and then ELB just has its own account to call ACM or KMS and say, I want to get the certificate and I want to get its private key. And I'm ELB, so trust me, right? We could have built it like that. We didn't build it like that. Because that wouldn't be great, right? Again, if the system were compromised, there'd just be this incredibly precious key sitting there that could be used to get any customer's certificate or private key. No, that is not good. Instead, what we have are a system called forward access sessions, and this uses a cryptographic chain of custody to do these kind of on behalf operations. And the way it works is that when the customer calls ELB, that call gets authenticated by the IAM service, which is this ring-fenced hermetic system. And the IAM service says, yeah, that's a valid call, authenticated, good ELB, you can handle that call. And here's a token. And that token is ephemeral, right? Lasts a very, very, very short period of time. And it's that token that ELB then uses to fetch the certificate or private key, right? And if it doesn't have that token, it can't get it, right? So ELB, the only way you can fetch the customer certificate or fetch their private key is because it has that token, and the only way it gets that token is because it recently got a correctly signed authenticated request from the customer. So if you just imagine that ELP as a service or a control plane or whatever part you want to think of it, imagine it had a vulnerability or an issue was somehow compromised. Well, access to that system wouldn't mean that, they can just fetch arbitrary certificates or keys or whatever, because they wouldn't have those tokens. And that's what contingent auth looks like in cases like that. We use this same pattern when we're doing things like granting access to EC2 for an EBS volume encryption key, or when services are launching private link endpoints into folks' VPCs, or attaching VPC gateways. I could give you countless examples of times we use this pattern. And then the other kind of contingent authorization that we do is, well, we never, if it's not a hermetic system, like I'm about to get to in level 5, that implies though there is some potential for access to that system. Now, with level 3, we've made sure that any of that access is fully auditable, fully traceable, everything can be seen, but we still want that access to be contingent. We don't want people just sitting around with like passwords or login capabilities. Instead, we want multiple people to have to sign off on any access, right? Hey, I need emergency access to this system. Okay, well, okay, I agree it's an emergency. Let's do it, right? That's what we call our break glass procedures, where, if you need it, if there's some event going on or some reason why, access might be needed, there are ways to get it, but they trigger strong accountability and involve multiple people and review and approval and so on. And then we also want this for any operational tooling or scripts and so on. We don't want just like an SSH service sitting around that somebody could just go execute anything on. Instead, we want each script pre-vetted and approved on a case-by-case basis. And that script can run, it can do its operations. We've made sure they're safe. They don't disclose customer data or do anything like that. And that's how we think about it. These are increasingly important properties. The if you want to build or replicate some of this kind of behavior as a customer, one interesting way is Amazon API Gateway supports Lambda authorizers, where you can write Lambda functions that can implement contingent auth. They can say, hey, only allow an operation if two people have approved it, or if we're in this emergency state, or whatever. But that's contingent authorization in a nutshell. Now, contingent authorization, um, common in AWS, but is not common in other environments that I've looked at. Although, there I'm sure are other environments out there that handle secret material and very sensitive data and so on that may have implemented similar controls. And this all brings me to hermetic systems, which is, for now at least, the highest level. One thing I learned in numbering this framework is, you can very easily make the mistake of putting one as your highest level, right? But then you don't have room to ever ratchet things up. So always number the other way around. So for now, at least, 5 hermetic systems is our highest level. And the concept of hermetic systems is to build systems where there's just no general purpose or operator access. Like there's just no way, right? And so at AWS, the examples we talk about publicly are like the Nitro system and the key management service, AWS KMS. Both are hermetic systems where people can't just go log in or run arbitrary commands or have very flexible APIs that just let them query data or anything like that. Instead, every interaction with these systems is via secure authenticated APIs. Everything is pre-vetted to make sure it can't disclose data. And these systems typically have to incorporate a secure root of trust. You have to know that the software you trust is the software that's running, and you usually need attestation mechanisms to be able to check all that and stuff and so on. And um, and for Nitro, we took this even a level further, where we took the majority of the Nitro system and we run it on physically separate cards, like not even the same hardware that's running the EC2 instance. So it's a level further again, where imagine there is some issue or vulnerability in that stack was happening on literally a different processor, a different memory than where the customer instance is. Um, for our bare metal instances, that's pretty much the whole story, because the customer just gets the hardware. On our virtualized instances, we also run the Nitro hypervisor, and I'll talk a bit more about that. Now, when we were designing this, right, our goal was we want to build a system that customers can run arbitrary computation on, an incredibly flexible system. Um, but we don't want to see inside. We don't want to know what's going on, right? Now, the kind of golden ideal for that, like the utopian solution for this, is something called homomorphic encryption or fully homomorphic encryption, which is a form of computation that allows um, arbitrary processing of encrypted data, right? And it's a real thing. It really works. And we have all sorts of research happening on this and work. You can read our cryptographic computing page. But the short version is it's also incredibly slow, like billions of times slower than normal computation. And it's not something practical for, an arbitrary application or most workloads. So that wasn't something we could use. Still isn't something we can really use. The idea of running an EC2 instance inside fully homomorphic encryption is just not remotely practical for anybody. So the next question we asked is, okay, well, we can't do it with fully homomorphic encryption. Can we use memory encryption? Can we just encrypt the memory that the EC2 instance has and make it invisible to us? And the answer is yes. And we do this on Graviton and some other platforms coming. That you can use memory encryption, and that can protect the memory in a way where anybody else doesn't have access to that encrypted memory. As long as you're careful to keep the keys segmented and all this kind of stuff. But we don't like it. At least we don't like it as a primary control. We don't think it's secure enough, and I'll tell you why. So when you encrypt something, right, it's the idea is you take the plain text and you employ encryption algorithm, and it should look like noise. It should just look completely like noise, right? But the problem is, if you change the data, someone with access to the encrypted version can still see what changed and where, right? Now, for data at rest, documents, hard drives, like that's not too big a deal for a few reasons. One is the data is not changing that much, and it's changing at a very slow rate. And the other is um, those kinds of encryption are use authenticated encryption, which means um, an attacker or somebody can't also, change any of the bits and see what happens. But memory encryption, because of the way CPUs work, doesn't get really either of those benefits. Data that's in memory changes a lot. And obviously, because of this property, the patterns of how it changes they're just visible, even with encryption enabled. And it turns out being able to see those patterns is enough to be able to figure out a lot of things about that data. This is how side channels work in general. This is how microarchitectural side channels work. In fact, microarchitectural side channels are mostly about just getting as far as being able to see the patterns. And the step of going from seeing the patterns to figuring out what the data is, it's actually considered the easy part, the relatively trivial part. But in with memory encryption, you actually that's your starting point. You can straight away see the patterns of changes in what is changing in the memory, and then because this is unauthenticated, you can also change the memory and see what happens, which gives you even more information. So in our opinion, that's not a strong level of protection. And we have memory encryption, we'll use it as an extra layer of defense, but our preference is that we not even be able to see the encrypted memory. We just do not want to have access to it because we just don't want to deal with all those side channels and think about it like that. So, um, and another point I should say is that CPUs don't operate on encrypted data. So when the CPU actually operates on your piece of data, it has to be decrypted. So it gets decrypted on its way into the CPU registers to actually handle operations. And if there are other side channels or issues in the CPU, like that memory protection doesn't help you at all. Um, so, so in Nitro, we instead wanted strong isolation from day one, like physical separation where possible. Don't even share the same memory um, buses or regions between some big important things. And we want to have dedicated components in isolation. So, for example, we never share a CPU core or an L1 or an L2 cache between like a customer EC2 instance and another EC2 instance, or even between those instances and ourselves. And we just don't even want to be able to see that memory and address it. And so in the Nitro system, we've got the Nitro layer, including the hypervisor, is deliberately isolating itself. And when it starts up, the way it works is I'm going to say that's customer's memory, this is my memory. Never the two can overlap or separate, and even the hypervisor isolates itself from the customer memory. And there's some creative work that goes in to make sure that even in cases where we have live migration and we need to be able to move EC2 instances from one box to another, there's like a dedicated live migration agent, and that's the only thing that has access to that memory, and it's dedicated per customer, and it's not and it uses end-to-end authentication and attestation and encryption and all the rest. And all of these little I's have to be dotted and T's have to be crossed. And these are important aspects of how the Nitro system is designed. But the net is that it just does not have access to the data, and ideally, even if there's a bug or an issue in the Nitro hypervisor, it won't get it. And there's certainly no way for me to just run some command or call some API or whatever, and like now I've got customer data, right? Or now I've got customer memory. It's just designed to achieve the opposite. Just have no operational access, no general purpose access. This is what makes it hermetic. Now, of course, if it's a software system, in part at least, I mean, the security is enforced in hardware, right? All that memory isolation, the physical isolation, those are all hardware level properties. But if we wrote the software in a way where it could just circumvent those things, that would be no good, right? So every build is signed, and every operation is pre-vetted. We've got some interesting testing procedures that give us very high confidence that the system isn't able to disclose data. that it shouldn't have access to. We run the Nitro system in a highly isolated network. We've made sure none of our debugging features disclose data, and so on. And this is a model we love and have been extending to more and more systems. It's cool. And I mentioned already that on Graviton we already encrypt all the memory. We'll have more to share about more platforms later. And it gives, this is how we build hermetic systems, right? This is what we mean by that, right? You've built a system where even the folks who operate it, they just don't have access to anything. Now, I'm going to pause there for a second because I've seen some questions, and then we'll get into how customers can build some of this. So let's see. Are there any other principles of zero trust that AWS employs internally besides CP4 and PKI? Any concepts around Linux host monitoring to ensure that other processes sneaked in? Yeah, absolutely. I mean, we were really early in terms of zero trust, and that we were doing zero trust before it was called zero trust. It's just long been that all those calls have been authenticated. But yeah, we run on-host monitors, things like AuditD are big parts of our accountability story. That where we're doing like Linux kernel unbypassable, level audit controls of like what gets executed on every system. So that we know that even if a process was taken over or something like that, we would have visibility into that. But I will say, like, it's not just that we like run something like AuditD or have those controls in the systems. Like, that's hard enough to do, and we have done that. But I think what's even more important is that when we've also built the systems at scale that can take that data and distill it down to like, hey, every manager gets a report about anything that happened on systems belonging to their team. That manager's manager, that manager's VP, and so on has visibility. And in fact, if somebody did something they shouldn't have, it won't work for the most part, but we'll still know. and we have business processes that can identify that and make sure it's escalated and visible, right the way up through a reporting chain. And that's an important part of level 3 for us. And then let's see. Love to see more about how forward access sessions are implemented. I think we probably will start sharing more about that in the future. And then somebody asked, why not add integrity protection, as well as for memory encryption? Yeah, there's just too much overhead. You got it. You got the reason right there. So for durable data, it's normal to add, say, a MAC or a tag along with the data. And that generally means you have to do like a SHA, like these days, SHA-256, or a GCM computation to make sure it hasn't been changed. That is way too expensive for what a CPU is doing in real time, and just would kill performance. And so that's why it's not there. It also because tags take up space, would change the memory alignment or the memory layout, right? So if you think about it, right, there's kind of two ways to do it. You can either have the memory that you're encrypting and then the tag, and then some more memory encrypting and its tag and so on, or you can have all the memory together and then all the tags together. Well, you don't want that second way because that's really not compatible with how CPU prefetching pipelines work. It would be awful because you'd be having to fetch data from very dislocated, disjoint places. And if you do it the first way, well, now your memory layout, like, it just doesn't fit anymore because you need to somehow squeeze data where there was no gap, so it actually implies like a kind of a really core low-level architectural change in how the CPU works and things like the TLB and stuff like that. It's pretty interesting. All right, so we'll get back to, we've invested a lot. We've built these things at scale, and building the Nitro system or KMS, no small feats. A lot of people, a lot of time worked on this. So this stuff needs to be easier. right? Because we know customers need the same levels of protection for the data that they manage on behalf of their customers, right? And I think that's a really important thing for the world. Every time I see a data breach out there, I just think there can be really awful consequences. People's social security numbers, they can't really change, just getting disclosed, or people's private, text messages and photos or stuff like that, just stuff the world has no entitlement to. And and as an industry, we have to provide easier mechanisms for everybody to be able to handle data sets in ways that are hermetic, right? And so 2 years ago, we launched Nitro Enclaves, which is our take on making it much, much easier to operate like a level 5 system, like a fully hermetic system. And the idea with Nitro Enclaves is to take all the benefits of the Nitro system and then just give them in a way that customers can get those benefits too, right? So we took care of the part where we can't see the customer's data. They just get that by default. Um, it's that's just what we think people should have, but we want customers to be able to do the same for their users. And so the idea with Nitro Enclaves is, customer runs an EC2 instance as normal. They get to pick any EC2 instance size they like, as long as it's below or above just a very small minimum. It has to have at least 2 CPU cores, so that's four vCPUs, and and they get to pick anything within that constraint, and they just launch and run it as normal, and then they can run a command on the instance that basically says launch this enclave, and they provide an enclave image. We actually have a really easy way to go from a Docker image to an enclave image, and the Nitro system will then carve a virtual machine, like a highly isolated virtual machine, and run that image inside that enclave virtual machine. And it is highly isolated by default. Like, it is basically like a box at the other end of a serial cable. It is has got no durable storage, no network access, no interactive access, no network services, nothing. It is a virtual machine just there to run your code. And the only way in or out of that system is over this virtual socket, a vSock, so that's like the serial cable that's connected between the EC2 instance and the enclave. And then we've got a helper agent that lets that enclave use that vSock to communicate with the external world using end-to-end encryption. So in ways where the EC2 instance, the parent instance we call it, has no insight, has no idea what's going on with that communication inside the vSock. It's just got no visibility at all. The way this works typically, right, you can run any operating system or application inside the enclave. It's incredibly flexible. It's designed so that normal mortal software development teams can just go do this. They don't have to be like low-level CPU experts or anything like that. They could just write it in any programming language they want, any framework they like, any operating system they can run on a virtual machine. And when that application starts up, they have that application generate a local public-private key pair, right? And that private key lives and dies with that enclave. When that enclave is shut down, that enclave key is like poof, out of existence. No one ever knew it, right? Lives and dies with that enclave. And the enclave supplies the public key, right? And it gives it to a little local service. It uses something called a hypercall. And that service is the Nitro attestation service. And the Nitro attestation service responds back with an attestation document. And that document has all sorts of things in it. It has, well, the public key, a checksum of the enclave image, the kernel checksum, the application checksum, the instance it was attached to, when it was launched, what region it was in, all that kind of stuff, right? All in this document. And then that document can be used for remote attestation, right? The enclave can export that document. It's safe to export. There's nothing secret in it. And anything can look at that document and go, well, that document is signed by the Nitro PKI. So if I trust Nitro, then I can believe everything that's in that document. And I'm going to look at that document and say, hey, the checksum is the one I believe it should be. That is the application I trust. So I'm actually going to give some data to that application because I've audited that application. I know it can't do anything stupid with that data. It can't disclose the data. It's just going to do the secure processing needed on that data and then reveal whatever the safe results are. And so, I'm going to check that checksum. Yep, it's the one I like. Okay, here, send it some secret material. And I can send it secret material because I've got that public key. So I can encrypt it with the public key. We've made this pretty easy because we've actually got first class integration with KMS and ACM. So all of this can be actually boiled down to writing a really simple IAM policy that says, hey, let this enclave with this checksum have access to this key, and then just go use that key to encrypt data as normal, right? So it's like a huge time saver. I mean, like you're basically leapfrogging years and years of effort it took us to build Nitro, and you get the same benefits. You can build a hermetic system that can process data. And so now, even if the EC2 instance is compromised, right, or even if there's some rogue operator who has access to it, doesn't matter. They can't see what's going on inside the enclave, which is, I think, a really good benefit. So that's all the levels. I think the main takeaways I'd love people to take from this are um, the biggest mistake we made in this whole effort, which is probably over 10 years in progress, was um, not having thorough enough feedback processes so that we could make sure we weren't making things too inconvenient for team members and folks operating and so on. And we've learned to get much better at that and build have mechanisms to build consensus and make sustainable changes and so on. That reducing privileges and adding controls is just a central way to securing modern systems. Enable CloudTrail and config if you haven't, and really think about building hermetic systems if you haven't already. And I think it's an advantage for businesses. It directly reduces the likely harm from any potential breaches or anything like that. And I think it is. I've never met a customer or an end user who didn't care about privacy. Everybody does. So it's a potential selling point for every business too. Um, this whole talk, everything's the first time we're really getting into any of this in a meaty way and talking about this framework. If you find it useful, let us know. Um, I'm probably going to be publishing a lot more detail from it. And anything you'd love to learn more about or see more detail, tell me. All right, I've got some more questions. We will see. JD Bean asks, how should we think about balancing the desire for a level 5 system with the operational challenges it seems to bring with? Any best practices you picked up? That's a good question. JD works here, so he's a good plant. He knows what to ask. A level 5 system is when you hermetically seal a system, it's operating in the dark, right? So and that is a bit of a trade-off, right? When things go wrong, it will be harder to debug that system intentionally, right? I think that nets out, once you get used to it, it's a good thing because you'll be able to, get better and better at testing. And production is not a great place to find out about bugs. And you might have to adapt to that pattern of, if you do hit a bug in production, working with your end user or customer to replicate it somewhere else that you can look inside, and everybody knows you can look inside. But it does have that implication. It does not come for free. I don't mean to sell it as like a utopian panacea or anything like that. Security never works like that, unfortunately. What is the best way to get secrets into the enclave? Well, I explained, but yeah, just encrypt them with a public key and sneak them in. Attestation only works for enclaves, right? There's no way to attest to base VM. Well, the enclaves are a VM, so you're testing the whole VM, the whole enclave VM. If you'd like to attest the instance itself, the parent instance itself, take a look at Nitro TPM, which we launched. And we'd love to make that easier and easier. So there are ways to do that. Of course, I should say that AWS has always authenticated and checked every machine image. So when you upload an AMI or you make a snapshot that you'd like to boot from, that's all done via secure authenticated APIs. We've got all sorts of controls around. And those are the only things we launch. And all of that is on the AWS side of the shared responsibility model. So we've kind of long I don't want to say been immune to, but it's just not really relevant for us. Like that whole kind of threat model that Secure Boot is built for just isn't really relevant to the cloud environment because you kind of already always had a secure mechanism that's like, yes, you're uploading the secure data and it's, that's all that's going to be allowed to boot. Um, so the traditional, secure boot reasons for attestation and so on, um, they can be useful because you might need to integrate with other things that kind of assume that world, but not quite as relevant to the kind of cloud threat model. That was everything. Thanks for the questions. This was fun. Um, this is going to be archived on Twitch. I will definitely archive it on YouTube as well. If you notice any slight difference in the Twitch templates, that is because I had to recreate them from scratch because I changed laptops. And we still don't have a way in Twitch Studio to export and import the stream, the scenes, but I'll be bugging them about that. Great. I'm probably going to do another stream next week or so, and I've got a topic built up in my head for that, but it'll probably be much shorter and more direct software development centric. Thank you, everybody. Stay well. Any feedback as well, just send it to me on Twitter or anywhere you can reach me. And have a great weekend.